So we've already looked at solving some quadratic equations by factoring, and we noticed that there was a certain type of quadratic equation that could be written like this, or maybe I should say that quadratic equations that are in this particular form become particularly easy to solve, where we have x plus a number squared, all of that is equal to some other number, because I can just take the square root of both sides, and then I have two relatively easy equations to solve. So I'm going to use a method that's called completing the square to take any quadratic equation that's in this particular form and rewrite it into a form that looks something like this, and making it a little easier to solve. This is especially useful with the quadratic equations that don't factor very nicely. So let's try an example and see what I mean. Something like this: x squared plus 8x minus 3 is equal to 0. I'm going to turn this into that form of x plus something all squared is equal to a constant on the right-hand side. So to do this, the first thing I'm going to do is just move the 3 over to the right-hand side of the equation. Okay, so x squared plus 8x is equal to 3. Now what I'd like to do is to add something to the left-hand side of the equation to make this a perfect square trinomial. In other words, to make this a trinomial that factors into x plus something squared. So we have a method of doing this. The method is to take whatever b is, divide it by 2, and then square it. So in this case, b is equal to 8. So I'll take 8 divided by 2, and then square it, or I'm just looking at doing 4 squared, or 16. So I'm going to actually add 16, and the idea is that now x squared plus 8x plus 16 is a perfect square trinomial. In fact, it factors into x plus 4 squared, so that's pretty nice. Now the problem is I can't just add 16 to one side of an equation, though. I need to also add it to the other side just to keep things equal and make sure the equation is still legitimate. So make sure you do that. So now we're dealing with x plus 4 quantity squared is equal to 19. Now a hint to knowing what this number is going to be is it's always whatever number gets squared. If you think about why it works, it makes sense. If you kind of keep this on the side and you keep the number squared, you always know what this comes out to factor. It's not too bad when we're dealing with whole numbers, but whenever we're dealing with fractions, and we have to factor things with fractions, then it becomes a lot nicer once you have that number there. So from here I can just solve this by taking the square root of both sides. And I'll end up with two smaller equations. X plus 4 is equal to square root of 19, and x plus 4 is equal to the negative square root of 19. And then I can solve these individually. So I'll get x is equal to the square root of 19 minus 4, and x is equal to the negative square root of 19 minus 4. And these are the two answers to this. So you can see why you couldn't factor this particular one, but using the difference of squares, it's not too bad. Let's try another example. Something like this: 2x squared minus 4x minus 5 is equal to 0. Now the main thing we have to remember for these equations is that before we can complete the square, we can't have a leading coefficient that's anything other than a 1. So this 2 doesn't work for completing the square. We're going to have to do something to get rid of it. And I'll show you what. But first let's move over the 5. And now before I complete the square, this has to be a 1 in front of the x squared. So I can take care of this by just dividing by 2 through the entire equation. So I can divide everything by 2. Of course, you have to do it on both sides. So this will become 1x squared minus 2x is equal to 5 divided by 2. And this is totally fine because I did it to the same thing to both sides of the equation. Now that this is a leading coefficient of 1, I can complete the square. So what am I going to have to add? Well, I'm going to take b divided by 2 and square it. In this case, b is negative 2. So negative 2 divided by 2 squared, which is negative 1 squared, or just 1. So I need to add a positive 1 to both sides of my equation. This left-hand side will factor into x minus 1 squared, and if you want a hint, it's always this number here, minus 1, minus 1. And then 5/2 plus 1, that's going to be 7/2. Take the square root of both sides now, and I'll get x minus 1 is equal to the square root of 7/2, or x minus 1 is equal to the negative square root of 7/2, and then just add 1 to both sides, and I'll get the square root of 7/2 plus 1, or x is equal to the negative square root of 7/2 plus 1, and these are my two answers. So let's try one more of these. We'll take 2x squared plus 3x minus 1 is equal to 0. The first thing, again, I'm going to move the constant over, so 2x squared plus 3x is equal to 1. Now remember, I have to get rid of this leading coefficient, so I need to go through and divide everything through by 2. So now we're getting x squared here, and then 3 divided by 2x here, and then 1 divided by 2 is 1/2. Now that I have this, I can start completing the square, since this is a 1 over here. So again, I'm going to take b over 2 squared. This is what I'm going to add. So I'm looking for what I should use here to fill in the blanks. And I should take b divided by 2 squared. In this case, this will be 3/2 divided by 2 squared. If you think about 3/2 divided by 2, that's the same thing as 3/2 times 1/2. So this will be 3/4 squared. So we should be adding 9/16. And it's good to have this part written here, the 3/4 and then squared, because that's going to tell us, it's going to help us out when we actually get to the factoring phase of the completing the square. So here we go. This is x squared plus 3/2 x plus, we want to add 9/16 on both sides. Okay. Now I said it can be hard to factor these when you have fractions involved, but remember, I know this is just going to factor into x plus 3/4 squared. Okay, because 3/4 times 3/4 is 9/16. 3/4 plus 3/4 will be 6/4 or 3/2. But again, this is kind of a shortcut here to help you know which one it is. And then 1/2, we can think of this as 8/16 plus 9/16, so this will be 17/16. So now what we need to do is take the square root of both sides. So we'll get x plus 3/4 is equal to the square root of 17 over 16, or x plus 3/4 is equal to the negative square root of 17 over 16. So these are the two values that we'll end up getting. Now here's a trick though. Since square root we can think of as just an exponent to the 1/2 power, I can distribute out the square root to the 17 and the 16. So really this is going to be the square root of 17 over 4. This is still okay, but this is probably a better way of writing this. Okay. And then over here I'll get x plus 3/4 is equal to negative square root of 17 over 4. And then I just want to subtract over the 3/4 from both sides. So I'll end up getting x is equal to the square root of 17 over 4 minus 3/4, or x is equal to the negative square root of 17 over 4 minus 3/4, and these are our two answers. So you can see that sometimes with our completing the square, we can get answers that are not so nice looking, but the process for solving them always stays the same. So as long as you're good on your arithmetic, you shouldn't be able to solve these without too many problems.